His mom and my mom. His mom and I are the same age.
So she's like 45.
Really? We graduated the same year.
She's only 40. What year is she born in?
My mom's like 30.
I don't know. All right, here we go. Today we start introducing what the real chapter is about. As I told the other class, the stuff that's up here on the board, I tried cramming it into the first section and then we never got done. And so this actually ends up being a really good day for it because obviously it's a shorter day anyway with maths. But this is basically going to be introductions to what we're going to do. So the first thing that we talk about is something called a polyhedron. So a polyhedron needs to be a three-dimensional object with flat surfaces. So when I do this section, I always like to use a Kleenex box, right? A box, any kind of box, but a Kleenex box that's not open yet is a perfect example of this, right? So when we're talking about this, it's got to have flat sides, all right? Flat surfaces. From there, the flat surfaces are called faces. So all of the flat surfaces that you see is called a face. The face is going to be some polygon. It can honestly be any polygon that we want, but when we zone in on prisms and pyramids, we're going to specifically have a couple different kinds of polygons. Where those faces meet, so these long straight pieces, where they meet are called edges. And where the edges meet, so we connect two edges, where the edges meet at each little point is either a point or a vertex. Now again, you might have known all that stuff. No big deal if you did, no big deal if you didn't. I just want you to know that going forward. So, what is this shape? What is this polyhedron? What would you call this if I asked you what's this name? A rectangular prism, right? Everybody agree with that? So from here then, if I asked you what are my shapes in a rectangular prism, what would you say?
Square and
Rectangles, right? We don't know if this is a square or not, but they're all definitely rectangles, right? So the faces in a prism are always rectangles.
Isn't there a triangular prism?
It could be a triangular prism. Okay.
There's no rectangles.
Yes, there are. So what are the faces? The faces are what I would call the guts, the middle of it. So that's where it gets confusing with a rectangular prism compared to a triangular prism. If I asked you right now, what is the base of this, what would you tell me? The bottom?
I'd say the two sides.
Okay, so Bryn's going to say the bottom, and whatever she says, then the other one that's opposite of it has to be. Kaden said it, she thought it was these two. Okay, so these two are the bases, but notice what's my guts? They're all rectangles, right? Even if I did these two, the guts are all rectangles, right? Braden likes to be different, so he's going to say it's the front and the back because he's looking at the front, and he considers that the base. But if he does that, look, all my faces are still rectangles, right? So the base is always going to have two bases in a prism. And the base is how you name the prism. So this is where Larissa's triangular prism would work, right? If I would call these two the base of this, but then pluck those off, cut them out, and put triangles on the end here, no matter how it's sitting, if it's sitting on the triangles or not sitting on the triangles, because there's triangles in it, then we would call it a triangular prism. And in between those two triangles would still be rectangles. That makes sense? So the base is how I name the prism. It can be any polygon, and they're always going to be parallel to each other. That's how you know that they are the bases. But the other way that you would know that it's the bases is like Larissa said. If it's a triangular prism, I would have to have triangles somewhere. It could be an octagonal prism. It could be a heptagonal prism. It could be any kind of gon prism. All right? And you would then just know that they're parallel to each other and everything else is a rectangle. We will get more in depth in this. Okay? This is just kind of like a brief introduction. From there, then, we go on to a pyramid, and what's the biggest difference between a prism and a pyramid? They all meet at one point, okay? What else? Think about a pyramid, and what's the biggest difference between a pyramid and a prism?
It has one base.
It only has one base now, okay? So it meets at a point, and it only has one base. And again, that base is going to be how I name it. So if it's a triangle, it's a triangular pyramid. If it's an octagon, it's an octagonal pyramid, right? The other big difference is all the faces in a pyramid are going to be triangles. Right? So think about a pyramid. I think I got one of these back here. If I think about a pyramid, oh, perfect. Sitting out and everything, right? So this is my pyramid, right? My base is a square, definitely a rectangle, could be a square. And then we have our pyramid. But notice all the sides are triangles compared to all of my sides being rectangles. Okay?
The base for the triangular pyramid.
Then this would have to be a triangle too.
No, a prism I meant. Like
Yep.
if it was on that, it would still be the bottom or?
It doesn't matter. Wherever the triangles are, even if you would put the triangles here and set it like this, because these are triangles, you would know that it's a triangular prism.
But it doesn't matter where.
It doesn't have to sit on the base necessarily. Okay? Make
So
sense?
the triangles are the base though.
Yes.
Oh.
Yes. But they might not necessarily be sitting on that base. All right? Okay with those two? Then we get into a cylinder, which is basically a what? Pop can. Right? But it's basically a prism, but instead of the bases being a flat surface, it would be a what? What is the base of a cylinder? A circle, right? So a prism with circular bases. And then obviously we're going to introduce the word height in a cylinder. Oh, and sorry, before I forget, if you look right back here at this pyramid, the key word to a pyramid that we'll talk about is a slant height. That's something that you probably haven't gotten into a whole lot. So that's just another vocab word. But again, we'll get more in depth in that and learn about it as we get into each section. Each one of these will be a different section. So where were we? Cylinders will have a height, and the height is the distance between the two bases. And then we have a cone. So a cone to me is a lot like a pyramid because it still meets at a point, but obviously our base now is a circle instead of a shape. And that's what makes a cone a cone. And again, we'll have a slant height in that, and something called an axis. And then what's a sphere?
Circle.
It's a ball.
It's a ball, right? It's a ball basically made up of a bunch of circles. Okay? So again, those are just introductions. We'll get more in depth in every single section that we do after this. Okay, and we'll talk about the surface area and the volume. I'm not gonna lie to you, sometimes this gets a little complex. Okay, but there's a lot of formulas in this. This is where we're emphasizing between lowercase letters and capital letters. This is going to be huge, this chapter. Okay, between capital B and little b, for instance, or lowercase b. All right. The last thing that they talk about on this is something called a cross section. Okay, the cross section to me is this: if I had some kind of shape and I had a huge samurai sword, okay, and somebody threw my shape up in the thing, and I hit it with my samurai sword and I whacked it in half. Okay, as soon as I picked up my pieces, I could look at the inside, and it would have some kind of shape in there because of how I cut my whatever box, for instance, right? So if I would chop mine right straight down like this and I open it up, what would the shape be inside that you could see? It'd be a rectangle, right? So when they talk about cross sections, they're just going to say, basically, think about slicing your whatever in half by the way that they tell you, and then opening it up, and they want you to draw the figure that you would see from making that chop. Okay? So it might be a triangle, it might be a pentagon, it could be any shape that we want. You just have to draw it. And that's what they were talking about by cross sections. Okay? That's it. You only got 8 problems. Okay?
So that cross section.
The cross section thing?